Hi, my name is Sanjana, and I have worked on the PERCIEVE project in spring 2017, and I'm going to be explaining my contribution. I have worked towards building a vulnerability knowledge database for discourse feature extraction, and this, as you can see, is my Capstone project poster. The objective I was trying to, this of course is a small piece of a much larger project, the PERCIEVE project, and the part of the work that I was doing, the objective is to provide a vulnerability knowledge source, which is like a comprehensive vulnerability database, and also to explore the preliminary analysis and to do the initial exploratory analysis to support predicting vulnerabilities from hacker discourse. What this means in simple terms would be I built the vulnerability database, which later on would help in classifying or checking the logic of classification for the CVE details types, and actually having a logical classification of the vulnerability data types to further work towards the similarity analysis from the email corpora. This figure shows the vulnerability database structure. As you can see, there are three main data sources from which the vulnerability database entries are derived from: CVE Mitre, NVD, and CVE details. I have also mentioned on the second node of the tree, CVE Mitre references have been I've used CVE Mitre references, SCCS and CVSS scores for NVD, and the vulnerability type for CVE details, as you know, is for checking the logic of the classification of vulnerability types. To give you a brief description of each of the data sources, we have CVE Mitre, NVD, and CVE details. CVE Mitre, you can go on to cve.mitre.org to view the website where we've got the data from. It's a government website. It's collected by Mitre. All the vulnerability the database is built by Mitre, and each of it's publicly open, and each of the vulnerability entry contains a description, it's uniquely identified by a CVE ID, and it has various fields. It's a huge XML file. It has a nested table structure, and it has a lot of information about the CWE ID, which is the weakness ID. It has information about the reference. It has information about the vendors. What I did in this was I used references to identify to actually subset a smaller number of words, which can be further helpful to identify vulnerability discourse. I want to show you my NVD my CVE Mitre notebook. It has an introduction, a small introduction about the databases, why I'm doing this, and the way I've done it. I've used XML tree of Python, and this was a little hard because there are about 60 or more references, and each one of them have a different regex, and it was slightly challenging to get that done. But this is the code for that, and our final result is this. You can see the visualization in CVE Mitre introduction under notebooks in the GitHub profile, and as we can see that BID reference constitutes a huge percentage of, or is the most predominant reference in our vulnerability. Moving on to NVD. NVD is built on, it's again a government collected website. It is publicly available also. NVD is the National Vulnerability Database, and it is and all the data entries are provided as an XML feed. You can either download you can download an XML file for either all the years together from 1988 up to 2017, or you can choose a particular year, you can choose a particular month, and you'll get the entries required for that. What NVD adds on to CVE Mitre is they've evaluated severity scores, and that scores tell you how what the threat level is of each vulnerability, and that's the value added on to CVE Mitre. Also, NVD database is not as big in volume as CVE Mitre, or the number of entries as CVE Mitre, because they do not consider reserved entries. What I did in this was I evaluated the CVE ID. So what CVE ID really means is there might be many vulnerabilities, but they might all come under one weakness. First of all, they may or may not have a CWE ID. They did not specifically be associated with the CWE ID. But if they are, it is possible for multiple vulnerabilities to be associated with one CVE ID. This is my notebook, NVD introduction notebook, and here in my motivation I've mentioned that I'm checking the correlation of CVE coverage, if there is any. And again, I've used XML tree to pass all the files into CSV. All the CSV files are available for direct download on our Google Drive. You can click here and find it if you don't want to go through the whole process of extracting them and merging them. Again, I've used pandas and bokeh to do the visualization. Here I've tried to count the vulnerability type for each month, and I've checked its CVE coverage, and I'm checking what months is the most active over a couple of years. Okay, coming to CVE details, this is the last one. And CVE details was supposed to be, or is created to provide a user-friendly interface for NVD's XML feeds. They've partitioned, as I mentioned a little earlier, that they've partitioned the XML feed and defined it into 13 vulnerability types. What I did in using this was, so this is an example. I've used SQL injection of the year 2016. This is the database. It's saved onto a data frame, and I've done a couple of filters and grouping. Using bokeh, I've visualized the count of vulnerability types and how they pan out across the whole database, how frequent each of them are. Here I'm checking the CWE coverage over those CVE details entries. Here I have the timeline for the different types of 13 different types of vulnerabilities over for the year 2016 and over different months. In this you can see that 10, 11, 12 or 10, 11 and the 4 and 4. These months are most show peaking activity, and the 9th month shows slightly lesser activity, and this is what we were trying to evaluate. That is my contribution to this project, and using all the databases using the resulting database that I got from all these 3 notebooks is what I created a vulnerability database from. Apart from this, I've also performed data set comparisons. I've analyzed the metrics across 3 databases, checked how the number of their entries vary, how how the description field changes over different databases. They're all available on GitHub, and that's my contribution to the project. Thank you.